afternoon. Welcome to Science with Agnes and Julia. Today we will be switching gears to talk about a chemistry topic rather than our typical physics ones.
Yes, today we will be investigating the chemistry of fireworks. Of course, we have all enjoyed a 4th of July fireworks show, but I would venture to guess not many of us understand the interesting chemistry behind those colorful explosions.
And that's why we're here. Let's begin with the structure of fireworks. The main part of a firework is the aerial shell, a small tube that contains explosive chemicals.
The explosive chemicals in the tube are composed of gunpowder and small globs of explosive materials called stars, which give the fireworks its color. So when you see a firework exploding, you can remember that the visible explosion is actually the stars inside the aerial tube exploding.
Each star contains 4 chemical ingredients: an oxidizing agent, a fuel, a metal-containing colorant, and a binder. The oxidizing agent reacts with fuel, which is gunpowder, to produce heat and gas in the presence of a flame or spark. The metal-containing colorant produces the color, and the binder holds the oxidizing agents, fuel, and colorants together.
Now let's discuss the 2-step process that occurs when the fireworks explode. The first step is when the firework is shot into the air. This is achieved by placing the shell into a tube that is partially buried in sand or dirt, called a mortar. There is a lifting charge of gunpowder attached to the fast-acting fuse that is placed below the shell. This gunpowder explodes and creates heat and gas that produce a buildup of pressure beneath the shell.
And, of course, the increase in pressure launches the firework. This brings us to the second step, when the firework explodes in the air. Once the firework is in the air, a time delay fuse in the aerial shell ignites, in turn igniting the gunpowder and the stars. As a result, there is a rapid production of gas and heat, which causes the shell to burst open. Hopefully, this reminds you guys of something that you learned in your chemistry class, Charles's gas law. In case you can't remember, this law states that as the temperature of the enclosed gas increases, the volume also increases, so long as the pressure is constant. In fact, the gases in fireworks expand faster than the speed of sound, resulting in a type of shockwave called a sonic boom. This boom is the loud noise we hear when we watch fireworks.
Right you are. Now let's move on to discuss a few technical aspects of fireworks. Within the tube component, if the stars are arranged randomly in the aerial shell, they will explode evenly. Likewise, purposeful arrangement of the stars will result in different shapes. The takeoff and the consequent explosion is considered both a high and low explosive. The lift charge is a low explosive and must be calculated perfectly so the burning fuse detonates the stars and gunpowder at the apex of the fireworks flight. This is the high explosive element of fireworks.
Of course, true fireworks aren't complete without a redox reaction. As we said earlier, the oxidizing agent is an essential aspect. This oxidizing agent reacts to release oxygen. A few common oxidizers are nitrates, chlorates, and perchlorates. Each of these oxidizers have individual characteristics that affect the chemical reactions. Nitrates are the most commonly used and are the most stable because they only release a third of their oxygen. Chlorates, however, are much more reactive because they give away all of their oxygen. This makes the chlorates very unstable. Sometimes just dropping them on the ground can detonate them. Perchlorates donate all of their oxygen, which also makes them unstable, similar to chlorates.
Once the oxygen is released, it reacts with the reducing component of the gunpowder. Usually the reducing agent burns the oxygen from the oxidizing reagent to produce hot gas, which is basically the energy released in the different wavelengths resulting in different colors. Should we do that? Yeah. Okay.